another language?
So this is some geometry review, but also we're going to take it to new heights and depths. Heights and depths. Okay, does everyone remember SOHCAHTOA? That's okay. Here it is. Now you know it. What does SOHCAHTOA stand for? What's the S stand for? Sine. Sine, and the O stands for? Opposite over hypotenuse. Okay, so SOH. C stands for cosine, which equals adjacent over hypotenuse. Yep, and then T is tangents. Yep, opposite over adjacent. Okay, so this is an abbreviation here to help you remember which one's which. And there's a lot of stuff that you can do with this, as you guys are about to find out over the course of the next 2 months. There's a lot you can do. So we have a triangle. When we write this, notice too that it's always sine of an angle. So it's just like square root can't be empty. Natural log cannot be empty. There's got to be something in there. Sine, cosine, tangent also cannot be empty. There needs to be something in there. And it's always going to be an angle measure. The most common variable that we use to represent angles is the Greek letter theta. And we just do that because that's what we do. So be really careful. Some people like to do their zeros. When they do zero, they do like a little line through it. Don't do that anymore. Kind of looks like theta. No one in here did it, but someone in my 7th period did it the other day. I told him to stop. I told him to cease and desist. No, we use theta because like the Greeks discovered all this stuff. They came up with it, so they use their alphabet. So sine of theta. Here's theta in this right triangle, right there. Boom. Sine is opposite leg over the hypotenuse. So what is opposite that angle theta? 4. The 4. Yes. And then what is the hypotenuse? 5. Nice. Okay, cosine is the adjacent leg. Which is the adjacent leg? 3 over 5. Nice. Okay, we tracking? Turn to your partner. What is tangent of theta? Okay, so tangent would be it's opposite over adjacent, so it's 4 over 3. So all of this too is from the angle's point of view. Opposite means opposite the angle. Okay, so we've got some new fun ones to add. These ones don't even have their own buttons on the calculator. Yeah, I know. It's crazy. We're also not going to use calculators for another couple months, so. Yeah. So this is called cosecant. And cosecant equals 1 divided by sine theta. It's the reciprocal of sine. So it would be 5 over 4. It's the reciprocal. Okay. SEC is secant. And it is 1 over cosine of theta. So what would that be in terms of this triangle here? 5 over 3, yeah. So we're just turning the fraction upside down. Anyone guess the name of that bottom one? Cotangents. Truly. Cotangent is the only one with a name that makes sense. It's 1 over tangent. Which would be what? 3 over 4. Is anyone bothered by the fact that cosecant matches with sine, but secant matches with cosine? It bothers me too. Like, Like, shouldn't cosecant go cosine? No, it doesn't. The way that I like to remember it is, I don't know, it bothers me. There's one co per row. So we've got cosecant in the first row, cosine in the second row, cotangent in the third row. If you don't like that rhyme, if you think it's dumb, I don't care. Since these are reciprocals, right? Same thing, like we're turning the numbers over. It also means that the legs of the triangle that we're doing are reversed. So cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. Cotangent is adjacent over opposite. There's not really a nice like abbreviation for this. Shoshikal, yeah, it's not as fun. So I would say just stick with SOHCAHTOA and remember that these ones are the other ones turned upside down. Wow, page 1 done. That was so fast. All right. Okay, a correction to make. We are going to not say on the unit circle because that's not correct. We are going to say on a graph. And I'm going to add in some axes here. This is the XY plane. So immediately making a connection to what we were doing last class. Okay. The circle is kind of there as a guide, basically to give the hypotenuse length, sort of. I don't know, it's kind of weird. We'll just do some examples and it'll start to make more sense. It's kind of hard to explain where this circle comes from. So in this setting, we'll see a lot more examples of this, but our triangles will always be drawn so that the right angle is on the x-axis. That's a little angle symbol. And so there's basically four different orientations that a triangle could have, one for each quadrant. So if our triangle was in the second quadrant, it would look like this. If our triangle was in the third quadrant, it would look like this. And if our triangle was in the fourth quadrant, it would look like this. Now, these triangles could be different sizes, but what I'm talking about is the orientation of them, where the angle is located. Tim?
Can the right angle like never be on the origin?
Correct. Yeah. Theta is always at the origin. So maybe I'll draw some, these are our possibilities here. Put them off to the side there. Okay. Everybody go like this. Everybody go like this. Okay, this represents how you're going to draw the triangles, right? We have like one leg, the other leg like that, or they could go like this, or they could go like this. Everybody do this. Yeah, go back and forth a little bit. This is a good dance move. You can break it out at prom, homecoming next year, in the club, once you're old enough. The people love it. Okay, this is to remind you how to draw the triangles. when the triangles are on the coordinate plane like this, since theta is always here at the origin, and our triangles are always drawn like this, it means the y coordinate here, the y side, notice it's y because it's like in the y direction, y-axis, is always going to be opposite theta. Y is the opposite side in all of these triangles. See that? That's why we draw them like that. And so we would say that sine, since it's opposite over hypotenuse, is going to be y over r. What is r? R is the hypotenuse. What does r stand for? The radius. The radius. So x is like an x coordinate. Y is the y coordinate. And r is the radius of the circle. Cosine, what would cosine be? X over r. Nice. And tangent would be y over x. Turn your partner, fill out cosecant, secant, cotangent. Okay, what's cosecant going to be? R over y. And secant, r over x. And then cotangent. Nice. Okay, so a couple little weird things that I think about to help me remember which one's which is, I don't know, maybe back in the day in the Middle Ages, maybe they spelled sine like this, you know? Probably not, but maybe they did. And that reminds me that y goes with sine. Okay? And then the other thing I like to remember is this made-up word, tannix. It's completely made up. I like to think of it as like maybe, you know, onyx evolves into steelix, evolves into tannix. I don't know. But this reminds me that it goes y over x. Okay? These are just little things that stick in my memory, and then I can remember, okay, tangent is y over x. Y goes with sine. Take them or leave them. I don't care. They work for me. Maybe they'll work for you. So, examples. Use coordinate 2, 5. So we're going to plot the point 2, 5 on the graph. And what this is going to represent is an angle in the first quadrant. And we're basically going to draw a triangle to fit that angle there. What is that triangle going to look like? It's going to look like this. So we're going to take, boom, boom, fill it in like that. Right angle on the axis, theta at the origin. And so what this is called a reference triangle. And we draw these so that we can figure out sine, cosine, tangent, etc. What does this bottom leg of the triangle equal? 2. It has a length of 2. What would this top leg here? 5, yeah. Oh, the hypotenuse equal. How about square root of 29? What? What?
Yeah.
What?
Oh.
Okay. This is not a 30, 60, 90 triangle or a 45, 45, 90 triangle. If it was a 30, 60, 90, it would go 2, 2 root 3, right? And then 4. It goes 2, 5. Okay, so not a 30, 60, 90. If it was a 45, 45, 90, it would go 2, 2, 2 root 2. Doesn't do that. We have 2 and 5. Okay, we have to use the good old-fashioned Pythagorean theorem, which is a squared plus b squared equals c squared. So I did 4 plus 25, took the square roots. We're going to have to do this. We don't have calculators, so we're just going to leave it as square root of 29. Simplify it if possible. It's not possible. Does everyone see how I got square root of 29? Tracking. So now we can find sine, cosine, tangent, cosecant, secant, cotangent for this angle theta right here that passes through the points 2, 5. Creates this triangle. Sine would be 5 over square root of 29. Cosecant would be square root of 29 over 5. What would cosine be? 2 over root 29. And secant would be? Root 29 over 2. Tangent would be 5 over 2. Cotangent would be 2 over 5. Is there anything else I need to do with these numbers? Yes. We need to get the radical out of the bottom. We need to rationalize. Okay, turn to your partner and say, do you have any questions? What would the up and down leg equal? Root 3. Anyone know what the hypotenuse would equal? It's 2. This is a 30, 60, 90, actually. How are we supposed to know that? Because I see a leg, and this one is root 3 times that leg. So this must be short leg, that must be long leg. Hypotenuse must be 2. But we could always check it out and make sure. Oh, it works. Okay, the hypotenuse is always positive. Here. I recognize that this leg is this leg times root 3. Then if I do 1 times square root of 3, I would get the length of the other one, which is the same pattern that I would expect to see in a 30, 60, 90. Like if this was 1, the long leg would be root 3. And that pattern only exists in 30, 60, 90s. So similarly, if I saw a triangle here and I was like, oh, this is 4 and this side is 2, I know the other side of the triangle. What is it?
2.
Not 2.
Oh, That's 46.
Yeah, it would be 2 root 3. Because I see that the hypotenuse is twice as long as one of the legs, which means this is a 30, 60, 90, and the other leg would be root 3 times that leg. So if I can recognize part of the pattern, I know the rest of the pattern.
So for like the what we talked about, and how like it has like a short side and then it has a long side. So if you're going from short to long, you would multiply by root 3, right? So
Mhm.
would it be negative?
Okay, that's a great question. So yeah, this is something that basically we're going to have to deal with a lot is what's the deal with negative sides and why is this side negative but not this side? It's 100% to do with where the triangle is located, what quadrant it's in. So because it's in the second quadrant and I'm going like left, I know that the x leg is always going to be negative. And I know that since it's going up, the y leg has to be positive, no matter what. Yeah. And the hypotenuse is also always positive, no matter what quadrant you're in, 100% of the time. So this is a weird thing to get used to, but it will always be the case. Again, if you don't recognize that this is 30, 60, 90, you can still do Pythagorean theorem, it still works. Do sine, cosine, tangent, cosecant, secant, cotangent for these with your partner. Ready, set, go. Okay. What does sine equal? Root 3 over 2. Cosine, negative 1 over 2. Tangent. Yeah, root 3. So we would do root 3 divided by negative 1. We would want to just write this as negative root 3 and fully simplify it. Cosecant, 2 root 3 over 3 after we rationalize, yes. Secant, negative 2. Cotangent, negative root 3 over 3. Okay. Okay. All right, so here's a different way of asking a question like this. So given that sine of theta equals negative 4 over 5, and that theta is between pi over 2 and pi. So the question is, what quadrant are we in? Turn to your partner, talk about it. What quadrant are we in? Good Lord, can't write today. Okay, so again, this is telling us where it is. Once we figure out how to read it, show me on one hand, where do you think it is? 1, 2, 3, 4. Quadrant 2. This is quadrant 2. Close. Okay, so here's how we know. A full circle is how many radians? Radians? 2 pi. 2 pi. So 2 pi is over there. Same place as 360. Which means that 180 would be the same as what? Pi. And so 90 would be what? 1/2 of pi, or aka pi over 2. What would 45 be? Pi over 4. Yeah. So see what's going on here? We're basically just dividing in half. We have 2 pi. Divide that in half. This would be 1 pi. Divide that in half would be pi over 2. Divide that in half would be pi over 4. So if I divided that in half, it would be pi over 8. Yeah, and that's like 22.5 or whatever. Not as cool, but that's what it would be. How about the one on the bottom? 270 degrees. What would that be in radians? Yes. 3 pi over 2 is how we'll write it. But yeah, so basically we're just counting like by halves. So we go 1 half, 2 halves, 3 halves, 2. More on this next class, don't worry. But really, yeah, it's just dividing it up into fractions. So like this would be pi over 4. This would be 3 pi over 4. 5 pi over 4. 7 pi over 4. We're gonna get into this. You're gonna have this memorized before you know it. Truly. You guys believe me? It's all right. Take it on faith. Okay, so don't need to know all that just now. Take a mental picture though. Here's what we need to know right now. We need to know that pi is here, 2 pi is here, pi over 2 is going to be there. So this triangle is in the second quadrant. And this is impossible. Okay, this is a bad question. This should be 4 over 5. Yeah, I was telling you guys to just look at this though. That can't be negative. Impossible. Okay, this triangle's in quadrant 2. What does it look like? Show me. Yes, this looks like this. So we can draw that. Boom, boom. Okay, it's telling me sine equals 4 over 5. How did I know that it couldn't be negative? Why was I getting ornery?
Well, if it was negative, then this thing, it would be down here.
The y coordinate?
Yeah, the y coordinate would be down here, and that would make the triangle itself, which has to be coordinate 3.
Yes. Yes. So if sine is negative, if sine was negative 4 over 5, this is telling me that the y coordinate is negative, which means it's in the bottom half of the graph. So that's why I knew if we're in quadrant 2, quadrant 2y is positive. There's no way we could have a negative sine value. Okay. So when we label this triangle, this is going to be 4. Hypotenuse is going to be 5. What is the other leg going to be?
3.
Not 3. Not 2. What? It's going to be negative 3. Okay, so when we do Pythagorean theorem, or you might remember 3, 4, 5 is a common right triangle. If we have 5 and 4, I would be doing 25 minus 16 gives me 9. Using Pythagorean theorem, take the square root, I get 3. But whether it's positive or negative depends on where it's located. So since the x-coordinate is going to the left, we've got to label it negative 3. So it kind of overrides our, oh, I calculated it and got 3, but it's in the second quadrant, so the x-coordinate has to be negative. Does that make sense?
Yes.
Okay. Fill out sine, cosine, tangent, cosecant, secant, cosine. What we get for sine? 4 over 5. Cosine. Tangent. Yeah, okay. So when you're writing fractions, It is 4 over -3, but this is not the correct way to write a fraction. It's not wrong, it's just like improper notation. So you would want to say -4/3. I know the 4 is not negative, it's the 3 that's negative, but still -4/3 is the correct way to write it. Or you could say negative, like you could say -4/3, or you could say -4/3, like that with the negative sign next to it. And that's just how you write fractions. I didn't make the rules. Okay, cosecant. 5/4, secant. There we go. And cotangent. Nice. Hey, how do we feel about this part? Looking at a triangle, filling out the trig values. Good? Great. How do we feel about figuring out where the triangle is based on the information? Terrible. Yeah, that's always the hardest part, and that's why we're going to do these examples right now. Okay. We'll do some more examples, too, that are a little more similar to what we were just doing. Actually, let's start with this. Okay, so add in a number 5 there, and we'll actually do that one first. Okay, turn to your partner. Number 5, what quadrant are we in? If you think you know it, hold it up. 3, my lord. Big 3. This will be quadrant 3. Quadrant 3. Got any Germans in here? I do 3 like this, apparently. I learned that from the movie Inglourious Basterds. Could we explain why it's 3? Yes. Okay, so where is pi? Can you point to where pi would be? Yes, pi would be this way. So pi is here. Where's 2 pi? 2 pi is here. Yeah, 3 pi over 2 is the same as 1.5 pi. That would be straight down. So it's saying it's between here and here. It's somewhere in there. We know that our triangle... Oh, what would our triangle look like? Yeah, there we go. There's our triangle. We don't have to draw the triangle, but that's where it would be. Does that make sense? So part of this is going to be just memorizing the locations of these numbers. Okay? And we will memorize it. Don't you worry. We know how to memorize. Okay, number 6, where would that be? Okay, where's 0? What's 0? Less convincing that time. 0 is this way. So 0 and 360, 0 and 2 pi are in the same spot. Where's pi over 2? Yeah, so we're between here and here. That means we're here, quadrant 1. What would our triangle look like? Yeah. Okay. Make sense? Once you have these locations memorized, I mean, this is telling us exactly where it is. The ones above it are a little weirder. So for number 1, we're told that sine, not again, please don't do this to me. Yeah. Can't win with this thing. Oh my gosh.
Oh, that's awesome.
Oh, it's that one. Okay. We can keep that one up there. I figured out the chord. It's this chord. You guys ever had to like change a TV antenna so that you get good signal? You guys even know what a TV antenna is?
Yeah.
Okay. Man, what a crazy time to grow up. Okay, so this is telling us that sine is less than 0. Which coordinate does sine go with? X or Y? Yeah. So sine goes with Y. So if we're being told that sine is negative, we're also being told that Y is negative. Those are saying the same thing. If the sine of a triangle is negative, it means our triangle looks like this, as a negative Y coordinate, which means it's in quadrants 3 or 4. Cosine is X. So we are being told that cosine is greater than 0, so it's quadrant 4, exactly. The only place where those are both true, quadrant 4. Oh my god. You guts. This is ridiculous. Can't win, you guys. Can't win. There we go. Okay. Here's a crazy one. Tangent. What is tangent again? Oh my Lancet check. Why is it so bad today? Maybe it's not that one. Maybe it's this one. Okay. Tangent is what over what? It's y over x. Okay. What would cause y divided by x to be negative? What makes y divided by x negative? One of them being negative, but not both, right? So if tangent is negative, what quadrants could we be in? 2 or not 3, 4. Okay, does this make sense? If I'm in quadrant 3, it would be a negative divided by a negative, because we have a negative y coordinate and negative x coordinate. So tangent is positive in quadrants 1 and 3. Tangent is negative in quadrants 2 and 4. This is telling us that cosine is positive. That means x is positive. So what quadrant do we have to be in? 4. Yeah. Okay. For number 3, cosecant, which one is that related to? Sine, cosine, tangent, which one? It's related to sine. So this is telling us the same thing at sine, when it's telling us that y is greater than 0. And we're also being told that x is less than 0. What quadrant would this be in? Where is y positive and x negative? Okay, this is quadrant 2, agree? Secant in number 4 goes with x, same as cosine. Cotangent, similar to tangent. It's going to have the same rules. See if you can figure out number 4 with your partner.
Okay, so.
Just like this is
So X is
in this quadrant, tangent is negative. That's X is negative. Talk about that. I have to try to quadrants.
or y over x is 2 that's 0. X negative. Exactly. So that way if you know which one it doesn't matter. So it's negative.
Oh.
So
But which one of these is
we know that because they're related.
does it think of it as a y? So I don't know. I don't know how to think of this because y over x is equals to 0. Just thinking of this as like a y. Yeah, but how do you know whether you're making x or y? Because it doesn't matter which one. You just need to know if it's on like this makes sense.
Yeah, so why about the S quadrant? Maybe it's you have it, you can have one and negative y.
Okay.
Because quadrant 2, if I did x divided by y, x is negative 1. For y is positive.
It's 3. Wait, how would it be 3? So how did you see that?
So,
Did I read that right?
x over y.
Yeah. Oh, x. Oh.
I mean, the order doesn't matter. It's the same as tangent 2.
And then, okay, but if it's x over y, it's greater than 0.
So in quadrant 2, x is negative.
Wait, I have a question.
One.
And why isn't this 1?
Oh, it is.
Right.
But that doesn't matter positive or negative. Like 5 or 1 over 5 or 5. Negative 5. Okay, what quadrant is this in? 3. This is in quadrant 3. So secant goes with which variable? X. Secant goes with x just like cosine. So if x is negative, what are my options? 2 or 3. Okay, cotangent is x divided by y. We need this to be positive. What would make x divided by y positive? Either if both are positive or both are negative. Where are they both positive? What quadrant would that be? Where both x and y are positive? That'd be quadrant 1. So quadrant 1 is a possibility. It doesn't overlap with this, so we know it's not the answer. Where would they both be negative? Quadrant 3. Okay. Where the two conditions overlap is the answer. There's even a little 3 in there. Look at that. What's that 3 doing? I don't know. How to get there? I don't know. Follow-up questions on that. Okay. I'm gonna write some things up here like this, and you're just gonna hold up on one hand what quadrant you think it's in. Okay, you don't need to write these down. We're just gonna do some drills. You can write them down if you want, but you don't need to. Just hold up a number. Hold up a number. Yes, 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 yes. 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 Yes, yes, yes. Okay, this is quadrant 1. Sine is telling us positive y coordinate. Could be there. Tangent is positive. Where's tangent positive? What quadrants? 1 and 3. So where they overlap with quadrant 1. Okay, where would this one be? Yes. 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 No. Yes. Yes. Nice. Yes. Yes. Okay, cosine is which coordinate? X. So this is telling me x is less than 0. It's on the left side of the graph. Cosecant goes with which coordinate? Y. So, I mean, this is a good question that Annabelle asked. Doesn't cosecant being negative really mean that 1 divided by y is negative? Yes, it does. But if y is a negative number, 1 over y will also be a negative number. If y is positive, this will also be positive. So to shortcut it, we just think about y being negative. Y is negative on the bottom of the graph. Quadrant 3 is where they overlap.